the universe keeps expanding continuously. In 1929, scientists discovered that the materials making up our bodies originated in the hearts of stars. By 1957, we came to understand that the sky is not only a stunning sight, but also a representation of the immense energy present in the universe. There is so much happening within the cosmos, much of which remains beyond our comprehension. We often ponder why we exist, why planets and stars are formed, and what other possible outcomes could have been. Many times we neglect issues until they become critical, even when we know that they will eventually affect us. Betelgeuse, one of the largest stars in the night sky, has begun to exhibit signs of instability, shaking violently, which could be a warning that something ominous is taking place. This star has attracted attention due to its colossal size. In fact, it is so enormous that our sun appears minuscule in comparison. Betelgeuse is not just any typical star. It is a red supergiant, much farther from Earth than it seems, situated over 640 light-years away. While this distance might not appear striking at first, in cosmic terms, it is vast. Even if we could travel at the speed of light, reaching Betelgeuse would take over 640 years, an impossible feat with today's technology. Under normal conditions, such a journey would span over 12 million years, a period far exceeding the entire human history. This emphasizes the immense size and power of this star, which has been vibrating intensely for a considerable time. Stars, although seemingly silent from our viewpoint, are anything but quiet. Scientists still have not fully deciphered the signals emitted by Betelgeuse. For years, it has been labeled as a pulsating red supergiant, with its brightness fluctuating in cycles, ranging from 10 to 100 days depending on whether the star is expanding or contracting. These gradual fluctuations demonstrate the dynamic nature of the star. Another fascinating aspect of Betelgeuse is the dramatic shifts in its brightness, varying between magnitude 5 and magnitude 0, marking a significant contrast compared to other stars. These brightness variations follow a cyclical pattern. The shortest cycle lasts approximately 185 days, while the longest spans around 2,335 days. On occasion, these changes occur more predictably and can be measured with precision. In February 2021, the V-band value of 1.1614 was one of the lowest recorded in recent years, showing a deviation from Betelgeuse's usual brightness. Its brightness is not the only remarkable feature. Its intense red hue is also striking, a result of its surface temperature of around 3,500 Kelvin, much cooler than the sun's temperature of 5,500 Kelvin. Even though the sun is smaller than Betelgeuse, the latter emits less energy per unit of surface area due to its lower temperature, making it appear less radiant despite being one of the largest stars known. Although Betelgeuse has remained relatively stable, despite being a pulsating giant, it has recently shifted from a calmer state into a more unstable one, which is concerning. The reason for this is that the gas surrounding Betelgeuse is burning, and the star is gradually depleting its hydrogen supply in its core, where fusion converts it into helium, a process that is expected for a red supergiant. As hydrogen fusion slows down in the core, the outer layers of the star begin to expand, causing the star to grow in size. During this phase, helium accumulates around the core, which is now predominantly hydrogen, and the process of helium shell burning begins. In this process, helium atoms fuse into heavier elements like oxygen and carbon, releasing energy that counteracts the gravity trying to compress the outer layers. However, the fusion of helium is not as stable as the fusion of hydrogen in the core, leading to accumulations of energy that are released irregularly. These releases can destabilize the structure of the star, causing its outer layers to expand and contract, resulting in pulsations that alter Betelgeuse's brightness. These pulsations release vast amounts of energy, producing powerful stellar winds that strip significant portions of mass from the outer layers of the star. This is a common phenomenon for red supergiants such as Betelgeuse. The stellar winds cause stars to lose mass, which affects the distribution of matter and energy inside the star and further influences its evolution. As the outer layers of the star expand when it grows and contract when it shrinks, a constant pulsation is generated, which we perceive as fluctuations in brightness, much like the beating of a heart. To study these phenomena, astronomers employ a range of techniques, with two of the most essential being photometry and spectroscopy. Photometry measures the amount of light emitted by a star at various times, allowing scientists to observe changes in its brightness. In the case of Betelgeuse, its pulsations provide insight into what is occurring inside the star. This technique directly connects to the star's behavior, enabling the monitoring of its luminosity variations. On the other hand, spectroscopy examines the star's light at different wavelengths, providing crucial information about its temperature and motion. When Betelgeuse pulses, its spectral lines change, revealing details about the processes driving these pulsations. These two methods help astronomers create a detailed understanding of stellar behavior by combining brightness data with internal structural analysis. Astrophysicists go even further by using powerful computer models to simulate the star's inner workings. These models solve equations that describe the star's structure, including the nuclear processes and fluid dynamics at its core. They predict how the star's pulsations will change in response to varying internal conditions, bridging theoretical models with real-world observations. A fascinating phenomenon occurring inside stars like Betelgeuse is stellar convection. Energy produced in the core moves towards the surface, balancing internal processes with the star's external brightness. As hot matter rises from the core and cooler matter descends, convection currents form, transporting energy to the outer layers. This movement of matter alters the star's luminosity, causing it to appear brighter when the energy reaches the surface. These fluctuations in energy flow, driven by convection currents, explain the periodic variations in brightness observed as pulsations. Furthermore, these pulsations are not random but follow regular patterns, especially in stars like Betelgeuse, which are classified as variable stars. The cycles of brightness are tied to the rhythmic expansion and contraction of the star's outer layers. As the star expands, its surface cools and dims, while during contraction, the surface heats up and becomes brighter. This process results from the intricate interactions between gravity and radiation pressure. Gravity pulls the star's matter inward, while the pressure from radiation generated in the core pushes outward. These forces create a delicate balance that leads to the periodic expansion and contraction of the star over time, which in turn causes the star to become noticeably brighter or dimmer when observed from Earth. Betelgeuse is nearing the end of its life as a red supergiant, exhibiting these convective and pulsating behaviors with greater intensity. As it exhausts its nuclear fuel, it will eventually explode in a supernova, marking the end of its life. Until that moment, the pulsations caused by stellar convection will continue to influence its luminosity, providing astronomers with invaluable insights into the internal dynamics of massive stars. As Betelgeuse continues to evolve and near the end of its life cycle, astronomers are closely monitoring its behavior for clues about the fate of other stars like it. Understanding its pulsations and how the star's structure reacts to internal changes is crucial to building a more complete picture of the life cycle of massive stars. By studying Betelgeuse's current phase as a red supergiant, scientists can gain important insights into the future of stars that are similar in size and mass, such as Antares and Rigel. While Betelgeuse is an exceptional case due to its proximity and visibility, its study is part of a broader effort to understand stellar evolution on a universal scale. The processes occurring within Betelgeuse are not unique to this star alone. Similar events are unfolding in other massive stars scattered throughout the cosmos. Some of these stars are far more distant, but their behavior could be studied indirectly through techniques like photometry and spectroscopy. Another aspect of studying stars like Betelgeuse is the possibility of observing a supernova explosion. A supernova marks the end of a star's life and is a dramatic event in which the star expels its outer layers into space, enriching the surrounding interstellar medium with heavy elements. These elements can then be incorporated into new stars, planets, and even life. The potential for Betelgeuse to go supernova has been the subject of intense interest among astronomers, as such an event would be a significant source of data on stellar death and the formation of new elements. However, predicting when Betelgeuse will undergo a supernova is challenging. It could happen in the next few thousand years, or it may take much longer. Despite the uncertainty, the study of its current activity helps scientists better understand how stars like Betelgeuse evolve as they burn through their nuclear fuel and transition through various stages of instability. The data gathered from Betelgeuse's pulsations is also contributing to the development of new models in stellar physics. By combining observational data with simulations, researchers are improving their understanding of how energy and matter behave inside massive stars, particularly during the late stages of their lives. This knowledge is essential for astrophysicists as they try to decipher the mechanisms that drive the behavior of stars, from their birth in stellar nurseries to their eventual deaths as supernovae. One of the exciting aspects of studying stars like Betelgeuse is the opportunity to witness the dynamic processes that unfold as stars near the end of their lives. The fusion of heavier elements in the star's core, the shifting balance between gravity and radiation pressure, and the resulting pulsations offer a fascinating glimpse into the forces that shape the universe. For astronomers, each new discovery about Betelgeuse's behavior provides a step closer to unlocking the mysteries of the cosmos. Although we can never fully comprehend the complexity of the processes happening within these distant stars, every piece of information we gain brings us closer to understanding the workings of the universe. As technology improves and our ability to observe these distant stars becomes more advanced, we can expect to learn even more about the forces that govern the life and death of stars. In the case of Betelgeuse, the journey of discovery is ongoing, and each new piece of data adds to our collective knowledge of the cosmos. Whether it's through the study of its pulsations, its brightness variations, or its eventual supernova explosion, the star continues to captivate the attention of astronomers. The information we gather from this star will ultimately help us understand not only Betelgeuse's fate, but also the fate of countless other stars throughout the universe. The universe is a vast, dynamic place, filled with countless stars, each following its own unique life cycle. Studying stars like Betelgeuse gives us a window into these processes and allows us to witness firsthand the incredible forces that shape the cosmos. From the birth of stars in nebulae to their explosive deaths in supernovae, every stage of a star's life offers valuable lessons about the nature of the universe and our place within it. The ongoing research and observations of Betelgeuse and other similar stars will continue to reveal new details about the fundamental processes that govern stellar behavior. As we push the boundaries of scientific understanding, we are uncovering the hidden mechanisms that shape the universe at its most fundamental levels. This quest for knowledge is not just about understanding distant stars, but also about deepening our understanding of the forces that have shaped the universe from its very beginning. Betelgeuse's pulsations, its instability, and its eventual fate as a supernova remind us of the dynamic and ever-changing nature of the cosmos. In many ways, these stellar events are a reflection of the universe itself, constantly evolving, constantly expanding, and filled with mysteries waiting to be uncovered. And as we continue to study these distant objects, we come closer to understanding the profound forces that govern the universe. Let me know your thoughts in the comments, and don't forget to like and subscribe to stay updated on the latest discoveries from the world of astronomy.